Hi everyone! Today we're going to talk about compound inequalities. Compound inequalities are kind of weird. It's where you have two different inequalities that work with the same number. So today your aim is that I can determine if a compound inequality is true or false. I can tell the difference between a compound and inequality and a compound or inequality. And we're going to talk about the difference between an and an or inequality in a second. Okay? Let's read. Linear inequalities tend to have an infinite amount of values for the replacement variable, typically x, that solves the inequality. Meaning that, you could, if x is greater than 9, infinite numbers are greater than 9, right? Sometimes we put two or more inequalities together and ask what x values make both true. And, that's what the and part is, and which makes either one or the other true. That's where the or comes in. You will deal with and or along with truth values the remainder of algebra. So let's discuss them in an exercise. Exercise 1. Consider each of the following compound, meaning more than one. Compound means more than one, like 2 or 3 or 4. Consider each of the following compound inequality statements. Determine the truth value of both inequalities and then determine the overall truth value. So what that means is we have to look at each inequality separately. So let's look at A. The first one is 7 greater than 3. Is that true? Yes. So I'm going to put a T for true. Let's put a capital T. So this is true. 7 is greater than 3, and 2 is less than 10. Both of these are true, so this entire thing is true. Okay? And means both have to be true. Alright? Let's take a look at B. Is 5 less than 10? Yes, so that's true. Is 11 greater than 20? No, that's not true. So because this is an and, both of them have to be true for the whole thing to be true. This is a false inequality. Okay? That's what and means. So over here on the side, if it's an and, it means both must be true. Alright? Let's take a look at C and D that uses or statements. C says negative 4 is less than 7. That's true. Or 8 is less than 2. 8's not less than 2. But or just means that 1 has to be true. Is at least one of these true? Yep, this first one is true, so the whole thing is true. Okay? It doesn't matter that this is false. It doesn't matter that this one is false. At least this one was true, so an or statement is true. Letter D says, is 3 greater than 6? Nope. Is 8 less than 5? Also nope. So this whole thing is false, because neither of them are true. Okay? So we can formalize this into a very, into another type of problem, right? Which of the following compound inequalities is false? So we're looking for the compound inequality that's false. Explain your reasoning by showing the truth values of each individual inequality. So showing the truth values, we're going to look at each individual inequality and say whether it's true or false. And then we're going to figure out if the whole thing is true or false. So number 1, is 5 greater than 2? Yes, that's true. Is 4 less than 1? Nope, that's false. But we're using an or, so this whole thing is true. Because this one, the 5 is less than 2, works. So number 1 is true. Number 2, sorry, I'm just changing my pen colors. Number 2, is 6 less than 5? Yes. And is 7 greater than or equal to 7? Also yes, and because this is an and, both of them have to be true, so this one is also true for both. Okay? Number 3, is 10 greater than 0? Yep. Is negative 3 less than 9? Also yes, and because it's an or, only one of these has to be true. They both are, so that one is also true. Finally, number 4 must be the wrong one because it's process elimination, and that's how that works in a multiple choice problem. But let's just look at the math. Is negative 2 less than 4? Yes, it's true. Is 5 greater than 7? Nope. And because it's an and, both of these would have to be true, and it's not, so this is a false compound inequality. And that's what we're looking for. We're looking for the one that is false, so that is my answer for number 2. Okay? Remember, Again, if it has an and, that means that both must be true. If it has an or, only one must be true. Okay? You have to memorize this. This is really important for compound inequalities. Alright? On the next page here, we have this formalized, right? Truth values for and or. Number one, a compound and statement. Let me use a different color. A compound and statement is true only if all of the individual statements are true. So we just said that, right? Both have to be true. A compound or statement will be true if at least one of its individual statements is true. And that's what we just said a second ago. At least one. Okay, now we can start to judge the truth values of inequalities that involve algebraic expressions. So for the ones that we just worked on, notice these were only numbers, right? We didn't work with any letters, we only worked with numbers. So now we're going to start talking about what happens when we involve letters and variables into the problem. Okay, so here's a really important thing to think about. A value of a variable is in the solution set of an equation or inequality if it makes it true, and is not in the solution set if it makes it false. And we've talked about this a lot, right? Something's a solution if it makes the equation true. If it makes the equation false, it's not a solution. Now, inequalities have many solutions. Equations have usually just one. So let's take a look at an example with algebra. Exercise 3. Determine if each of the following values of x is in the solution set to the compound inequalities given below. Okay, so we're looking for whether the given value of x is a solution set. What does that mean? That means that we have to plug x in and evaluate. So here they give us x plus 2, so this means we're plugging in. So is x equal to part of the solution set of x greater than negative 3 and x less than 5? So I'm going to plug in x equals 2, so I get 2 is greater than negative 3, and 2 is less than 5. I've replaced the x with 2, and now I have to think. Is 2 greater than negative 3? Yes, that's true. Is 2 less than 5? That's also true. So what does that mean? It means yes, x equals 2 is part of the solution set. Okay? Now, part B. I'm getting red all over here. Part B says, is x equal negative 4 part of the solution set? Because remember, we've talked about how inequalities have more than one. We just figured out that x... How did I just do that? How can I undo? Sweet, there we go. Sorry about that. Okay, so we just discovered that 2 is part of the solution set. Now it's saying, is x equals negative 4 part of the solution set? So we're just going to try plugging in negative 4 into our new inequality. So I have negative 4 less than or equal to negative 4, or negative 4 greater than 0. And now I'm going to think, is negative 4 less than or equal to negative 4? Yes, it's equal to it, so that's true. Is negative 4 greater than 0? Nope, it's false. So is negative 4 part of the solution set? Absolutely, because it's an or statement. If this was an and statement, it would be false because of this one not being true. But since or, I've got this one true one, so that means that yes, x equals negative 4 is part of the solution set. Okay? Try doing C and D on your own, plugging in the number they give you and seeing if it works with the equation. Okay? So pause the video, try on your own, and unpause when you're finished. Alright, welcome back. Let's take a look at our problems here. Letter C, we are plugging in 1 into these two solutions. Now these are a little bit different because we have to solve them. So I'm going to take 3 times, instead of x, I'm plugging in a 1, plus 8 is greater than 9, and sometimes I like to split them up so I know my work. I'm plugging in 1, so negative 2 times 1 plus 10 less than 7. Now I'm going to do PEMDAS. 3 times 1 is 3, plus 8 is greater than 9. 3 plus 8 is 11. Is 11 greater than 9? Yes, so that inequality is true when I plug in the number 1. On the right side, negative 2 times 1 is negative 2, plus 10 is less than 7. Negative 2 plus 10 is 8. Is 8 less than 7? No, it's false. So is 1 part of the solution set of my and inequality? No. X equals 1 is not. And it says here justify here, which I guess I forgot to put up here, but justify means explain. Explain why. So it's not part of the solution set because and inequalities require both to be true. Okay, that's my justification. Letter D, last one of this exercise. We're now plugging in x equals 5. So I have 2 times 5 minus 1 is less than 3, or 5 plus 7 over 2 equals 6. Now, just because the one on the right's not an equality doesn't mean we can't think about it being true. So 2 times 5 here is 10, minus 1, less than 3. 10 minus 1 is 9. Is 9 less than 3? Nope, that one's false, so we gotta hope this one's true. 5 plus 7 is 12. And 12 divided by 2 is 6. Does 6 equal 6? Yes, it's true. And because this is an OR statement, and we have at least that one being true, then yes, x equals 5 is part of the solution set. Because at least one of the inequalities is true. This is what they want you to do and they want you to justify. They want you to explain why. Okay? Last exercise is going to be talking about graphing. Okay? So graphing in compound inequality is very similar to graphing of regular inequality, and I'm going to remind you again of our rules. Let me rewrite this here. Let me move this down a little bit. Remember, if I have a less than or equal to sign, that is a closed circle going left. If I have a greater than or equal to sign, that's a closed circle going right. If I have a less than sign, that's an open circle going left, and a greater than sign, that's an open circle going right. So these we have to memorize, right? And we're going to apply the same idea to compound inequalities. So exercise 5 says on the number line below, shade in all the values of x that solve the compound inequality. In other words, shade in the compound inequality solution set. So for A, it wants us to list some values just to get an idea of where we're at. You don't have to do this every time, but it's just to get a good idea of our understanding of inequalities. So the first one says x is less than 7 and x has to be greater than negative 2. So what's a number that's less than negative 7 but greater than negative 2? So I'm thinking about numbers between negative 2 and 7. So negative 1 would work, 0 would work, 1 would work, 2, 3, and I could keep going all the way until what number? Up until 7. So what I'm going to do to show you this a little bit better, to graphing it, my pen is doing all kinds of crazy things. I'm going to use different colors to show you the graphing better. So I'm going to underline this inequality of x is less than 7. So I'm going to go to 7 on my number line, and I'm going to look here. That's this one right here. This one. So I'm going to have an open circle at 7 and an arrow pointing to the left. So like this, right? Now that's the first one, x is less than 7. The other one, I'm going to graph on the same number line. X is greater than or equal to negative 2, and I want this one right here, this closed circle going to the right. But I'm going to put it on negative 2, and notice that my arrow would be going this way. But I'm going to stop at the 7 because I don't want something greater than 7. So really my inequality is going to look like this. Okay, I don't need the arrows going either way because my inequality can't be less than negative 7. Sorry, my inequality can't be less than negative 2. It has to be greater than negative 2. And my inequality can't be greater than 7 because it says right here that x is less than 7. So this is the graph of my inequality right here. No arrows infinite for something like this. The other one's a little bit different. Okay, this one says x is greater than or equal to 5 or x is less than -1. Because it's an or statement, it means that either one has to be true. So list some values, well 6, 7, 8, right, because that's greater than 5. You know, or anything less than -1, -2, -3, -4. Whereas in this one had a and, meant both had to be true. I was very limited in what numbers I could pick because they both had to work. But here, or means, well, it's either this one or this one. It's like saying, like, I can go to either Burger King or McDonald's and find something I like to eat. It doesn't matter which one I go to. Versus someone that says, I have to go to Burger King for fries and McDonald's for a hamburger. I have to have both or I won't be happy, right? You have to go to both. Or you can pick and choose. I don't know if that was a very good analogy, but sometimes I like to think of math in terms of real life to help me get an idea of what these words mean, because it is confusing. Okay, so first we graph this one. X is greater than or equal to 5. So I need, again, this closed circle going to the right. So I have a closed circle going to the right here. And then the other one, I'm going to make green. X is less than -1. That's an open circle going to the left. Now these two don't overlap. These two go their separate directions, right? If we think about it, the only values that don't work here are these values in the middle. If I have x equals 0, that doesn't work for either one of these. It's not greater than 5. It's not greater than 5. And it's not less than -1. So x equals 0 is something that wouldn't work. Same thing with x equals 1. So this is very different than we have like a few values that just wouldn't work. Okay, so this is our introduction to compound inequalities. If you have any questions, you know how to reach out to me. Good luck on your fluency. Very similar to the mini lesson. And 4.4 is mastery with 4.3. Okay, so good luck.